Hi everyone, it's a pleasure to be here. Today I'm going to be talking about, as John said, an artificially intelligent mining value chain, and the important part there is real-time decision optimization in theory and in practice. When I say in practice, what gives me the right to actually tell you what that is? Just 1 second on IntelliSense. We've delivered a lot of benefit through this technology to a lot of very important mining companies across the globe. But when we talk about value chain, we have to start there. How can we talk about the intelligent or an artificially intelligent value chain when we have to actually think about it? And we've done this slide a lot of times in this conference, but I'm going to give it my shot. Really taking a look at this from how you would do artificial intelligence in real time. So data at the very start of our process is expensive and there's not a lot of it. As a result, there's a lot of risks. We do a lot of interpolation. With interpolation and not a lot of data, we plan at a macro level. Planning at a macro level forces us to then have a lack of adaptability when it comes to actually delivering that value. The limited adaptation essentially gives us unattainable goals. What we try and achieve when we deliver value means we all run around like headless chickens on a mine trying to solve fires, resulting in operational inefficiencies. All over, our data is often in silos, our people are in silos, and we want them to talk to each other. We have data barriers, we have people barriers, we have lots of operational challenges. And at the end of the day, if you manage to do all 4 of them well, the market at the end of the day dictates the price. IntelliSense focuses predominantly on those 3 in the middle: the plan, deliver, and track. So IntelliSense's view of this world starts at the bottom rather than the top. We talk about each one of these processes represented by an app, a configurable app we can put on any mine. All well and good, each one of those individually doing their thing, but we all know that we have to get to the next level, which is those apps talking to each other, cooperating. That's how you end up with an intelligent value chain. A chain in which crushing is talking to stockpiles and flotation is talking to trucks. That's the world we want to get to. How do we get there? We need to connect it all. We need to connect it through the one common thing that we all talk about, which is material. If we can track material, we can, in real time, we can make these connections. If you can make these connections, you can go up another level, ensuring that the rich data level downstream actually reconciles all the way back into where you identify and plan your value. If you can do that, you essentially have a way of understanding where to go next and how to plan best. All of that is very holistic, and what we want to talk about today is decision making. We don't make decisions on a holistic level like that on a regular basis. If you want to get down to real-time decision making, you have to think to yourself, where are real-time decisions being made? How we approach AI today, and a lot of digitalization, is not new. It was invented by people on the left-hand side of this diagram in very flash offices who have never really seen what it's like to work on a mine, but are very smart and do know what they're talking about. A very good-willed CEO or somebody manager would like to implement that, gives it to another fantastic team of innovation who eventually get it to somebody in operations, and finally is given to our actual operator, the person who's making the decisions in real time. There's a lot in between the person on the right of this diagram and left. And I would argue that potentially, yes, we need to follow this process, but let's start with the guy on the right. So here's an example of our product in action. The product is called Brains App. You can see it's often in a control room because that's where real-time AI can take place. It's where decisions are being made in real time. So we should ask ourselves, what's happening in these pictures? Well, these gentlemen, and hopefully some ladies at some point, are looking at thousands of different or hundreds of different variables in real time. They're understanding what's the best I can do with this process right now. They are trained from a number of different years and they know exactly what to do. They know the decision to make. However, how can we aid them minute by minute and almost replicate them as AI? ChatGPT is not the inspiration for IntelliSense. For me, this is the inspiration for IntelliSense. Many years ago when AI first came out, it was all about computer games beating human beings. What you can see here is Mario, who has been trained by AI, who's perfectly running around and doing the game as he goes. You can see on the top all the different decisions that Mario AI is making as changes happen as he comes. You can see the options he has on the right-hand side. If I push this button, push that button, what will happen next, and the neural networks between its outcome. My question to you is, could we make this almost human-like brain happen in real time in a mine? And my answer is yes. So today, this is the world's smartest thickener. It is using neural networks, as you can see, similar to what Mario was doing on the right. But every minute, it's going through decision-making. It's deciding what I need to do to get the best outcome from this minute and this second. On the left-hand side, you'll see what is normally shown in a control room, which would be your standard amount of data, which is coming in real time. But that area where all that action is happening is an hour into the future. We're predicting the future, we're simulating the future, and we're deciding, like a human brain, what to do next, every single minute. We can see the uncertainty spread around our decisions. Even the human brain, we know we're confident of certain things, but we're not that confident of others. And we need to get that transparency across to the actual final user. Let's talk about how we actually get there. Data in mining is not great. Interoperability, we have a lot of systems which create silos. We'd like to increase that. We'd like more APIs within the industry. We'd like more data to come around. And when the data does arrive without quality sensors like yourselves, which I encourage more sensors, we have to use math to solve essentially these problems. We create better data with your existing data in a concept called a virtual sensor. It is, in this case, a flotation circuit. We can get real-time variables of recovery, bubble size, gas holdup, and all of these. And this allows you to make real-time decisions about your recovery. Normally, these will come in 4 hours after a lab assay, but here we're doing it per cell from physics up. So all of this is based upon physics in real time. The other fun thing we can do with this is use it to fill missing data when we don't have it and we want to learn from it, or if we want to learn forward. So you can see on the left-hand side, in real time, the red line is when our sensors drop out, but the blue line is our machine learning, which continues on. It allows us to control better. It allows us to make decisions in real time. And it means we don't have to stop equipment and make maintenance. And we've also done that in the spatial area. We've filled GPS when we don't have GPS, which allows us to then go and do some of our modeling. The other thing to do is to look at, a lot of people ask, well, where is the faults in my data? And we're obviously here to help this. AI is only possible if we help the minds to get there. We run a semi-real-time reconciliation every basically 10 minutes, which runs through about 2 million scenarios until it hits about 60,000 of the same number. And so it's able to reconcile back feed grades, tonnages, whatever you want. In some ways, this is a holy grail of running this in real time and reconciling every single minute your mine. However, we're getting there. But millions of simulations every minute is hard. This allows that conversation to happen. The actual, based upon math, your feed grade was X. And we know that. right? Because we know some of these variables down on the right-hand side of this diagram. We know what the concentrate is. We can weigh it. It's a variable we know. Back calculate that all the way into what the feed grade was. Math doesn't lie. But that real-time stuff, now that we have the great data, how do we approach that? We've talked a lot about combining things. Machine learning is not everything, 100%, and it shouldn't be in mining. It's a grounded, physical-based industry. The data is crazy variant. It's unpredictable. It's not built for machine learning. It's built for a combo of these two. I say from day one when we started IntelliSense, you don't put a Ferrari in a mine. Machine learning at times is like putting a Ferrari on a mine. It doesn't work. It gives us advantages. It's quicker. It's more accurate potentially. It learns. It's the bee's knees. It is that Ferrari. However, we also don't run around with tractors, I guess, in this example, right? We don't do everything slow. We don't do everything accurate. We don't do everything based upon physics. We want this kind of, and I've told this is called a ute in Australia. We want a ute of an approach. To do that, we have this great recommendation engine, which is giving us what we need to do. But that thing about linking spatial data to time series data is the key here. Knowing where material came from and where it's going, and therefore making decisions, allows us to do that. The number one area that I'm a metallurgist that happens to create all of these issues is in our stockpile. If you're downstream of this, which block would you like to choose next, right? You're going to pick an orange one, right? And if you're expecting an orange one and it wasn't orange, it was one of these many other colors, this is what we need to look at. And so one of our apps is working to create these digital stockpiles in real time, understanding all the different properties, whether it be age, hardness, etc. And what this allows us to do is to create that push and pull link that we need to have, the conversations between metallurgists and geologists and mining, allowing basically the influence of material and how it affects those real-time decisions, right? So that thickener example I gave you where the decisions are being made in real time, that the geology and the things are being accounted for with that process. All that technology is great. However, the most important part is the people. And getting people to use this is not easy. We've taken a complete trust and transparency and explainability approach to our way of working. We provide uncertainty at every point in time. If we're not sure, we all like humble people. You know, I don't mind admitting I'm wrong from time to time. It makes, I think, people like me. I'm not sure, I hope. And the thing is, we would like a software to be humble as well. We don't want it to plow through when it has no idea. If we've not seen this material, it needs to say, I'm sorry, you're the expert. You're the human being, take over. And that happens a lot in mining. Changes happen. And these kind of, not errors, but uncertainties we have lead to this humbleness and transparency and explainability and opening up and making the people that we've actually making these real-time decisions feel warm and fuzzy inside. That's a nice thing. But in summary, in my last minute, if we're going to approach AI in mining from a practical point of view, then a theoretical point of view, start with the actual decision that people are making every minute. That's the best place to start. And don't try the best model on the planet just because it's AI. It doesn't work. A Ferrari doesn't work to make these. All models are wrong, but you want the most useful one. And then finally, the whole point of mining is to get us all to talk to each other. So please allow AI and these things to help communication, trust, and transparency, because with all of that, we'll actually not just have this crazy digital mind that somebody came up with in the city, we'll actually have something that people want to use on a mine. Thank you.